Okay, so if we look at number 4, it is kind of like our area model a little bit, where it's saying 4/5. This is 4/5 of some bigger original shape. And so remember our definition, 4 iterations of a fifth. So I need to figure out the value of a fifth so that I can have 5/5 to make a whole. So if I look this way, I only have, well, if I look this way, I have 4, which is good. If I look this way, I have 5. Well, I need 4 iterations of a fifth. So going vertically, I have 1, 2, 3, 4. So each column must be an iteration of a fifth, because I would have 1/5 there, another fifth, another fifth, another fifth, and that would be 4/5. So to get a whole, I must have 5/5. So I'm going to do 1, 2, 3, 4, 5, and that column 1, 2, 3, 4, 5, and that column 1, 2, 3, 4, 5, and that column 1, 2, 3, 4, 5, and that column. So that's the same shape, but now I need another column to get 5/5. So all of this must be the whole or the original shape, because if this is 4/5 of the shape, I would need another fifth to make the whole shape. And so figuring out what your 4 iterations of 1/5 is, again, notice if I went in the rows, I would have 5 rows, and that doesn't make sense because I know I have 4 sets of a fifth. So I need to look for where I can see 4 sets, and that would be vertically. All right, let's look at the next one. Number 5, it says, let's see, Caitlin gives, what is it, half of her candy bar to Ariana. Ariana gave 1/3 of her candy bar to them, and so forth. Okay, so, and then my explanation here would be, 5 sets of 1/5 make a whole. All right, so our number of, let's see, oh shoot. Okay, this one is supposed to be 3, by the way. I am sorry. So if you're like, oh, she did 4. No, I was looking at that 4, but I did do problem number 3 there. All right, let's look at number 5. All right, so in 5, I'm going to just kind of make a rectangular candy bar here. And so this is my whole candy bar. So right now my whole is the candy bar. And then it says Caitlin gave half of her candy bar to Ariana. So I'm going to cut it in half. And again, my half is of the whole at this point. So right now my whole is the candy bar. I took half of it. But then the next part says Ariana gave 1/3 of the candy she got to Cameron. So I was looking at the whole candy bar when I gave that much to Ariana. But now she's going to give 1/3 of just her portion. So now the whole is just her candy, and she is going to give 1/3 of that to Cameron. So, and again, it's easier to cut the opposite direction to kind of see what your units are. So when you cut when you take 1/3, don't go this way, because then you got to do this. It's just easier to cut it this way. So she gave 1/3 of what she got, and she's going to give that to Cameron. Okay, so A is what fraction of the did Cameron get? Well, Cameron, you can now see the new units is 1/6 of the whole candy bar. Okay, so 1/6 of the whole candy bar. All right, make a math drawing. Let's see, help you solve this problem, explain your solution. So basically, I just, I drew a picture, drew a rectangle, shaded 1/2 of it, and then cut it into thirds and shaded that piece. The answer is the fraction of the whole, which is 1/6. Okay, and then for part B, it says describe the different unit amounts that occur in A, and then discuss how one amount can be described with 2 different fractions. All right, so that's kind of where we're talking about the whole. So we have, first of all, we have the 1 is the whole candy bar, and then the half is half of that. All right, the second whole is the candy. So it's kind of weird, but that half becomes the whole. So the half, or the candy, Ariana has, then that becomes the whole. All right, and then next we take a third of that. So we take a third of the candy she has. Okay, and then when we go back to the answer, that 1/6, and I'll come over here, that 1/6 is actually the fraction of the whole candy bar again. So then we go back to the whole. So it's kind of like we start with the whole, then we focus on the half becoming the whole, and we take a third of that, and then we go back to the whole thing again and say, ooh, that's 1/6 of this whole. So lots of moving targets there, which gets a little crazy sometimes. All right, let's look at number 6. All right, so number 6 says, suppose you were used 2/3 of a cup of cocoa to make a batch of cookies, but you only have a third of a cup of cocoa. Okay, so let's draw a picture. And I'm going to cut it into thirds. So there's so again, my whole to start out with is a cup, and I have 2/3 of a cup. All right, and it says, what fraction of the recipe can you make? Okay, so you need, let's see, you only have a third of a cup of cocoa. So this is what you have. So this is what you need to make the recipe. This is what you have. And so if you notice, you only have enough to make half the recipe because you're comparing what you have to that amount, and that is half of it. One strip compared 1 out of the 2. So you can basically make half of the recipe. All right, and then the question is, use a math drawing, definition of fraction. Okay, so first of all, I shaded in 2/3, and then I shaded in 1/3, because I need 2/3 of a cup and I have 1/3 of a cup. And so then I compared the part that I have to the part that I needed. And again, it's nice that they're all in thirds. We didn't have to get a common denominator. So I have 1 part of the 2 parts needed, which is half a recipe. All right, and then for part B, it talks about, describe all the different fractions here. Okay, so we have a whole cup and we have 2/3 of it. And then we have a whole cup and we have 1/3 of it. But then notice our whole becomes the recipe. So this is 1 recipe. So now the 2/3 suddenly becomes our whole. And we're comparing this strip to that whole. And that's where that half comes in. So again, we have lots of moving targets for part B. We have 1 whole cup, and then we have the 2/3 and the 1/3 of that. But then the 2/3 of a cup becomes our whole recipe. And our 1/3 becomes half of that because it's 1 strip out of 2. And it becomes half of a recipe. So again, fractions have moving wholes all the time, which gets a little crazy sometimes. Okay, let's look at 8. All right, so 8 says 3/4 of a cup of snack food gives you your daily amount of calcium. All right, so 3/4 of a cup. So again, to begin with, we have a whole cup, but we have 3/4 of a cup, which is kind of basically what? 1 serving of calcium. So this is like, or no, daily value. So this is 1, I don't know. How about this is 1, I don't even know what to say. I want to say 100% of what you need of calcium you need. So this is our whole. This is what you need to eat in a day. All right. And so this 3/4 of a cup of snack food gives you 100% of the calcium you need in a day. Okay. And so then it says, what fraction of your daily value would 1 cup be? Okay. All right. So again, this gives you 100% of your calcium that you need in a day. So here we'll CA. Okay, this looks like California. All right, and then it says, okay, well, you know, what if you ate a whole cup of it, right? So happen if I decide to eat a whole cup. Again, my forks aren't very good here. So say this is what I decide to eat. All right, so if 3/4 of it is all the calcium I need in a day, then this is my whole. Eating these 3 little strips gives me all the calcium I need. I'm eating more than what I need. I'm eating 4 strips, but it takes 3 to make my whole. So that would be 4/3 or 1 1/3. I would be getting more calcium than what I need. So 4/3, we'll just say of the daily value of calcium. All right, so again, kind of going back to the other ones, my whole was, you know, the whole cup, right? Then suddenly my whole becomes just the 3 strips. I have 4 strips compared to the 3, so I have 4/3 or 1 1/3. All right, let's look at number 12. And again, trying these on your own first is always best. It'll help you the most on the test. It says, show a picture of the 3 pies, draw a copy of the 3 pies, shade in 3/8 of the combined area. Okay, so if you want to take 3/8, the problem is these guys are different sizes. You have kind of big, then you have kind of medium, and then you kind of have tiny. And so I can't shade in like, you know, like a little, like, oh, that much of it looks like 3/8. So basically, I do know, though, that if I shade in 3/8 of each of them, that would have to be 3/8 of the total. So if I shade in this guy, this guy, this guy, and I eat 3/8 of that pie, and then if I cut these into 8s, and I eat, and again, I'm not very good at cutting, sorry. If I eat 3/8 of that pie, and if the baby guy, which I'm not very good at either, but say I got 3/8 there, I don't know, let me try that again. Gotta cut those in little pieces. Okay, so say I eat 3/8 of this, pretend I'm not very good. Okay, so I can show you the book picture there. They use computers. It's way more prettier than me. But if I take 3/8 of this guy and eat it, 3/8 of this guy and eat it, 3/8 of this guy and eat it, I know that I've eaten 3/8 of the whole. Because if I do the big, medium, and small, and I take 3/8 of this, 3/8 of this, and 3/8, it has to be 3/8 of the entire shape, which it would be almost impossible for it to, you know, do that any other way. So that one would be hard to do other ways. All right, and then let's look at 18. Or in 18, all right, we have a kiddo saying that this is 9/12, and another one saying it's 9/4. Explain each of the 2 students' answer can be considered correct. And then write an unambiguous, meaning only one answer, right? Not confusing about the problem. Okay, so in this question, he says it's 9/12 because he views all of these 3 as his whole. So that's his 1. And so if that's his whole, and then he sees it shaded, and he's like, well, if this is my whole, I have 9 slices shaded out of what is there? 12 total. So that's the fraction that's shaded if all of this is his whole. Now, Carmina, she views this as her whole. So she thinks that just one rectangle is her whole. So when she looks at this picture, she's like, well, there's 1 whole, there's 2 wholes. And then I have 1/4 of the next whole. So I have 2 1/4. So he's right if all 3 is the whole. And she's right if 1 rectangle makes the whole. So either way. And then again, if I want it to be ambiguous, I would have to say like, if 1 rectangle is the whole, then I'd have to say like, what fraction represents the amount shaded. So if I said then, if 1 rectangle is the whole, so that just singular, 1 rectangle is the whole, what fraction represents the amount shaded? then her answer would be right. And if I change